Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about network layer in computer network. What is network layer? This is the third layer in OSI reference model. What are the two layers we discussed previously? Those are the physical layer as well as the data link layer. Physical layer and data link layer. These two layers briefly we discussed in previous sessions. Now we are moving into the next layer, that is the network layer, that is the third layer in OSI reference model. First, let us see the overview of network layer. So in this session we are going to be discussing about what is exactly network layer. We have to see the introduction about the network layer, and next we have to discuss about the what are the functions it is provided by the network layer, and next we have to discuss the what are the design issues in the network layer. We will discuss all these topics in today's session. First, let us see what is the introduction about the network layer. What is exactly network layer? Where exactly we are using the network layer in OSI reference model? This is the third layer in OSI reference model. I already told OSI is having how many layers? Total it is having the 7 layers. In these 7 layers, this is the third layer in OSI reference model. The two layers are, what are the two layers before the third layer? Data link layer and physical layer. Already we discussed those all topics, and now this is the third layer in the OSI reference model. The main function of this network layer is, it is talking about to transfer the network packets. Previously in data link layer, for transferring the data from node to node delivery, we are using the data link layer. And coming to here in network layer, transferring the network packets. Whatever the data in the form of, in the data link layer, we have to transfer the data in the form of frames. Whatever we are delivering the data, that is in the form of frames, means that is node to node delivery in the form of frames. And coming to the network layer, whatever data we are transferring, that is in the form of network packets from source to destination. Means from source to destination, whatever data we are transferring, that is in the form of packets. These packets means here it is in the data link layer, it is node to node delivery. Coming to here, it is host to host delivery. From sender host to receiver host delivery. Means this is the host connection. Means we are connecting to the network. That is nothing but the network layer. It is involved both at the sender host as well as the destination host. I already told host. The term host is used in the network layer because we are connecting through the network. That's why it is called as a host. From one host, sender host to we are connecting through the receiver host. That is nothing but network layer. At the source, what we are doing at the source host, it accepts the packets. Whatever packets are there, those we have to accept from the transport layer. See, the order in the OSI reference model, there is application layer, presentation layer, session layer, transport layer, data link, transport layer, network layer, data link layer, and finally physical layer, right? Physical layer. So, whatever data is coming from the transport layer, means from the transport layer, this is the sender side. This is the sender side. Here is the receiver side. Sender side is there, receiver side is there. Whatever data is coming from that transport layer, it accepts the packets. In the form of packets only, we have to accept the data in the network layer. At the same time, it encapsulates it in the datagrams. Means packets is also called as the datagrams, and then deliver the packets into the data link layer. Whatever packets are there in the network layer, that can be transferred to the data link layer. That is the main process of the source side. That is the sender side. That is the source host. It can further send to the receiver. Furtherly, it is sent to the receiver. That is the process of the source. And coming to the destination, what it will do? Means receiver side. Means the datagram is decapsulated. Whatever data we are sending, that datagram means packets we are sending, that packets is going to be extracted and delivered to the corresponding transport layer. Whatever we are receiving, here also network layer is there, transport layer is there, and data link layer is there. Whatever data we are receiving from the data link layer in the form of packets, right, in the network layer, that can be delivered to the transport layer. That is the extracted. We have to decapsulate. That is the destination side, destination host. This is the process of sending and receiving packets in network layer. And next, what are the main features it is supporting in the network layer? The main responsibility of the network layer is to carry the data in the form of packets from the source to destination without changing that data. With that, whatever data we have to send, that data we have to send exactly that data only. At the same time, that is in the form of packets because it is host to host connection from the source to destination. That is the main responsibility. And the next one is, if the packets are too large, suppose whatever packets we are sending, if that packets are too large for the delivery, they can be fragmented. Means we have to divide that particular packets into different smaller packets. That is the fragmented. And next one is, the next feature is, it decides the route to be taken by the packets. Means it can be decides the route also to packet to travel from the source to destination. That is also one of the feature. Means which route I have to go to transfer the data. That is also comes under the one of the feature of the network layer. Among the multiple routes, suppose if I want to go to see this particular place, this destination, I have number of routes to go to that particular place, to visit that particular place. Means which route I have to select to go to that particular place is nothing but the routing. Means if I want to reach from source to destination, there are multiple paths are there. In that multiple paths, we have to select the best path. That is the routing. And next one, the source and destination address to be added to the each and every packet. If we want to send some particular packet, each packet is having the source address as well as the destination address to that particular packet is going to be added in the network layer. That is, these are the some features of the network layer. And next one, what are the functions of the network layer? What are the main functions it is going to be provided? First one is addressing. Addressing is nothing but it is having the address of the source address as well as the destination address. Source and destination address. Means it maintains the address of the frame header, both at the source side and at the destination side. For performing the what? Addressing, to detect the various devices. Means which device I have to send the data, from which device I am receiving the data. That is nothing but the addressing. And next one is packeting. Packeting is nothing but it is going to be performed by the internet protocol. Means IP packets, internet protocol packets. That's why it is provided by the internet protocol. This network layer converts the packets from its upper layer. Whatever packets we are receiving the network layer, that can be transferred into the upper layer. And next one is the routing. What is routing here? It is the main important functionality in the network layer. Whenever we are going for the network layer topic, the main word is routing. What is exactly routing? Selecting the best path among the number of routes. Means it is the most important functionality. Means what exactly it is doing? The network layer chooses the most relevant and best path. We have to select the best path for transferring the data from source to destination among the multiple paths. That is the routing. We have to select the best path to transfer the data. To determine the route taken by the packets from the source to destination. How we are going to determine the best route? Using some routing algorithms. That is about the routing. How we are selecting exactly which route is the best route? Based on the routing algorithms only. That is about the routing. And next one is forwarding. What is forwarding? Moving the packets from the router's input to the appropriate router output. Means whatever packets are there, that we are moving from the router input to the router output. That is the forwarding. And next one is the internetworking. What is internetworking here? It works to deliver the logical connection. Internetworking is mainly for the logical connection across the multiple devices. Means multiple devices are there. There are the multiple devices for connection. The logical connection between the devices is called as the internetworking. Previously, whatever we used in the data link layer, that connection is the data link connection is the physical connection. Physical connection. Whatever connection is there in data link layer and physical layer, that connection is the physical connection that can be used by the MAC address. Here it is going, internetworking is talking about the logical connection. Means we are connecting from one IP to another IP. That means one network to another network. That is the logical connection. One host to another host among the multiple devices. That is the internetworking. What is congestion control? It is also one of the function in the network layer. Congestion is nothing but, mainly congestion is talking about the happens when there is too much data is going to be sent at the same time. So this is the rule. Number of users are sending the data at the same time only. Then that time here there may be traffic. Means suppose in real time example, if we are choosing one road, this is the road. Number of vehicles are coming in this particular road only. What will happen? Here some traffic is going to be happen. Here also multiple users are sent the data is the same route at the same time. Same route they select at the same time also. Then there may be congestion. Means that it causing to the slowdown. Just like a traffic congestion. on a busy road. How the busy road is going to be, traffic is going to be there, like that it is going to be congestion. This network congestion leads to the delay. Sometimes it can be data loss also. If it is a congestion, then there may be a data loss also. Means congestion is mainly nothing but it is talking about the traffic. Based on that, if congestion is going to be happen, automatically the data, that may be delay also, at the same time data loss also will be happen due to the congestion. And next one, this congestion control, to the methods used to prevent the network overload to ensure the smooth data flow, we are going to use the congestion control mechanisms to help to manage the traffic, so all the users can enjoy the stable and efficient network connection. We are using the congestion control methods. These are the some functions of the network layer. And next topic is the design issues of the network layer. What are the main design issues of the network layer? These are the 4 types of design issues are there. First one is store and forward packet switching. Store and forward packet switching. This is the first design issue. And the second one is services provided to the transport layer. And the third one is implementation of the connectionless service. And fourth one is implementation of the connection oriented services. These are the 4 design issues of the network layer. First, let us see one by one. First one is the store and forward packet switching. What is store and forward packet switching? Store and forward packet switching. Packet switching already we discussed previous class, that is the data link layer class, right? So, store and forward means what? The host sends the packet in the nearest router. In data link layer, we are talking about the frames. Here we are talking about store and forward packets, because it is a network layer. The host, whatever host there in the data link layer, that is a node to node delivery. Here, the host send the packet to the nearest router. Who is there in the nearest to that particular host, that will send to the first one. This packet is stored until it has fully arrived. If suppose this host send the data to this particular router, it will wait until receiving all the packet. After receiving all the packets, once the link is fully processed by the verifying the checksum, whether it will check whether I received all the data, then only it is going to be forwarded to the next router. Means after receiving total packet only, it is moving to the next router. Till this process continues till destination. That is a store and forward packet switching. This mechanism is called as store forward packet switching. Store means first, whenever it is going to be started, it will wait until the total packet is receiving. After that, till means it is going to be stored in the buffer. Afterwards, then only after receiving the total packet only, it will send to the next router. This total process till reaches to the destination, this process is going to be continued. That type of mechanism is called as the store and forward packet switching. And next one is the services provided to the transport layer. This is one of the design issue of the network layer. See here, services provided to transport layer. So how it is going to be? Services provided to transport layer. See, here is the transport layer. Here is network layer in OSI reference model. I am talking about OSI reference model. Here is the transport layer, network layer, data link layer. So here we are talking about the network layer design issue, right? How the services is going to be provided to the transport layer. How the services is going to be provided to the transport layer. See here, through the network or transport interface. Here in between transport layer and network layer, what it is called as interface. In previous classes already we told, this is the interface. Through the interface between the network and transport layer, the network layer transfer its services to the transport layer. Whatever services are there of the network layer, that can be transferred to the transport layer. These services as follows. See, what are the services? Before providing these services, the transport layer following first it must follow some goals. What are the goals? First, it can be offered the services must not depending on the router technology. Whatever services it is offering the network layer, that must not going to be depend on the router technology. That is the first condition. And the second condition is the transport layer needs to protected from the type, number, topology of the available routers. This is also one of the condition. Whenever the network layer providing the services to the network as transport layer, these are the conditions to follow. And the network addresses for the transport layer should be uniform numbering pattern also. Those are the LAN and WAN connections. These all have to follow whenever the service is provided to the transport layer. What are the based on the connections? There are two types of services. Means network layer providing the services, right? What are the services? Connectionless services, connection oriented services. These two services provided to the transport layer. These are the conditions. Whenever the network layer providing the services to the transport layer, we have to follow these conditions. Based on that, the two services are connectionless as well as the connection oriented services. So first one, connectionless services is talking about the routing and insertion of the packets into the subnet is done individually because it is connectionless. There is no connection between the packets. So it can done individually. And the next, no added setup is going to be required. That is the connectionless. Connection oriented is nothing but subnet must offer reliable service. Connection oriented is talking about what? Whenever the connection is there between the sender and receiver, that connection is reliable service. And all the packets must be transmitted over a single route. Means whatever packets are sending, right? Destinations and so many routes are there, but it will select the only single route. That is the connection oriented service. Connectionless, it will take multiple routes. These are the two services provided by the network layer to the transport layer. And the next design issue is the implementation of the connectionless service. What is the implementation of the connectionless service? So here we are talking about the connectionless service. Packets, whatever packets are there, those we can call as a datagrams also. These and corresponding subnet is called as the datagram subnet. So this is in this diagram, this whatever this circle is there, right? This oval, this is called as the subnet. So whatever packets we are transferring, those are called the datagrams. When the message size, whatever packet is there, whatever message we are taking, the size can be transmitted 4 times of the size of the packet. Compared to the actual size, if the message size is actual size more than the 4 times more than the actual size, then that time that can be divided into 4 packets. If it is 4 times larger than the actual size, it can be divided into 4 packets and transmit each and every packet to the router. See, whatever data is, suppose 1, 2, 3, 4 is there, this is the total packet, but it is having the more size, 4 times more size than the actual size. That's why it is going to be divided into 1, like 2, 3, 4. Like individually we are dividing the packets. This can be sent. This is the host, this is the sender side, this one is the sender, this one is the receiver. Process 1 and process 2. We are sending the data. Whatever packet is there, because it is a connectionless service, we can take any route for sending the data. So one packet is, suppose this is a one packet, it will take some route. Here it is going to be reached. So till here it is going to be reached. And coming to 2, we can take some more routes. Coming to 3, this is the route. Coming to 4, this is the route. Means this is a connectionless service. Means packet can take any route for sending the data from sender to the receiver. That is the process. Here this is the some device like router, switch, hub, like that. This is the LAN connection. Sender and receiver for sending the data. So here there is no prior setup of the routers. These whatever A, B, C, D, E, F, these all are called as the routers. These all are called as the routers. Whatever 1, 2, 3, 4, these are the packets. These are nothing but the routers. No prior setup of the routers are needed before transferring the data because it is the connectionless service and follows its own individual route. They did not follow any route. They follows their own individual route from source to destination. That is the main connectionless service. And next one, each data packet has destination address. So we are dividing the packets, right? But each and every packet having their destination address. Destination address is there in each and every packet, irrespective of the packets. Independently, it can be routed to the destination. That is the implementation of the connectionless service. The example for this service is, Internet Protocol. Internet Protocol, whatever is there, that is the IPv4, IPv6 all comes under the connectionless services. So this is the example of the implementation of the connectionless services. And implementation of the connection oriented service. To use the connection oriented service, first we have to establish the connection. It is connection oriented. That's why first we have to establish the connection. Then only it is talking about the forwarding the data. So in connection oriented services, the data packets are delivered to the receiver in the same order which we have to send by the sender. means it follow only one way for sending the data. So here from this process to this process, from this host to this host, there are number of routes are there, means A, B, C, D, E, F, these all called as the routers, right? So this is the subnet. This is the subnet. These are all called as the routers. So here whatever data is there, right, from sender to the receiver, what we are saying connection oriented means number of routes are there for sending the data, but it can choose only one route for sending the data. All packets, whatever packets we divided 1, 2, 3, 4, those all can be sent in only one route, only some particular dedicated route. That is nothing but the connection oriented services. It can be done either two ways. What are the two ways? Circuit switched connection, virtual circuit switched connection. See how it is circuit switched connection. It is a dedicated physical path is going to be there to establish the connection between the nodes, between the host. And next one is the virtual circuit switched connection is talking about the transfer to over the packet switched network in such a way it seems to user there is a dedicated path from the sender to the receiver, but it is virtual path is going to be established here. While other connections may also using the same path, means not only this connection, other connections also can be used this path. That is the virtual circuit switched connection. The example for this circuit switch implementation of connection oriented services MPLS, that is multi-protocol label switching. This is the example for implementation of the connection oriented services. And coming to the today's summary, first we discussed what is network layer, and next we discussed what are the different features, what are the different functions of the network layer, and next we discussed what are the different design issues of the network layer, what are the different design issues we are using in the network layer, all discussed in today's session. Thank you.